question for today. Find the pOH of 1.42 times 10 to the negative fifth moles of hydrogen sulfate dissolved into 4.61 liters of solution. Now, because this starts with an H, and also because it's being dissolved into water, it would classify as an acid. So before we even get started, we should expect the pH to be between 0 and 7, which means if you do 14 minus something between 0 and 7, then the pOH should be between 7 and 14. That's the acceptable range for what we're looking for. Also, before we can get started, this has 2 different hydrogens for every 1 molecule. That's a little bit goofy, because normally in this process you start with moles of hydrogen ion and you just go about your business. But because this one comes as a double, it's called a diatomic acid, then for every 1 mole of hydrogen sulfate, you're actually getting 2 moles of pure simple hydrogen ion, which means our first step is to figure out the number of moles of hydrogen. And that's coming from dimensional analysis that we've done in the other videos. Essentially, you only have to go down 1 simple hallway, and it involves the subscript 2 right here from molecules of hydrogen sulfate into ions of pure hydrogen. And that will give you, yeah, we're going to let you edit that.
Okay.
And that will give you there it is. 2.84 times 10 to the negative fifth moles of hydrogen. So we have a certain number of moles of hydrogen. We want to go diagonally down to the concentration of hydrogen, that was dividing by liters. Then we need to get pH, which was the negative log. Then from that answer we do 14 minus what you have, gives you the other item on the bottom row. So from the math on this, I highly recommend using the ANS button on the TI graphing calculators. That would be the second and then the negative sign. It's written in tiny little letters above the negative sign. ANS will copy paste the previous answer that you got. On the silver editions, you can also just simply press the up arrow button and then press enter. That will also copy paste. Very handy time-saving tactic. So we have this number for the number moles, and then in order to go diagonally down and to the left, we simply divide by liters. So if you take that, and then you notice in the original problem, we have 4.61 liters, so do the division there, and if your calculator agrees with mine, then you should get 6.1605 times 10 to the negative sixth. From here, this equals the concentration of hydrogen. So if that's what the problem asked for, then congratulations, you're finished, just stop there. But that's not what we wanted, so we need to keep moving around the diagram. To go from concentration of hydrogen to the pH, you simply do the negative log. So since this is already in your calculator, just type negative log, second negative sign, enter. And that should spit back 5.21038. This does not have any units. It's just pH, which is dimensionless, which means unitless. The previous answer, the dimensions there were actually moles per liter, because that's exactly what we did as far as the units are concerned. Once you do the negative log, it's just pH. But remember, if we were going to stop there, Make sure you round for significant figures. We are not stopping there though, because the original question asked for POH, which means we're on the bottom row. We just need 14 minus the number that you have. Again, make use of the answer button. And that should yield 8.7896. But because of significant figures, when we look back at the original, we had 3 here and 3 here, so our final answer should become 8.79 would be the correct POH for the situation described earlier. Thanks for watching, and I hope it helped. Leave comments in the comment section if you have questions or concerns, and we'll look for more of these videos in the future.